Hello dear students, once again you are welcome to the class of numerical skill. Our topic for today it is adjoint of matrix. It is a new topic, adjoint of a matrix. Let us check how to calculate adjoint and what it means, adjoint of a matrix. So adjoint of a matrix, it is a transpose of the matrix formed by cofactors of the elements of given square matrix. Transpose we know, and the cofactor also we already discussed. Transpose means it is the matrix obtained by interchanging the rows with the columns, so that it is transpose. Cofactor means it is minor into, we will discuss it, minus 1 whole raised to I plus j into minor we already discussed in the last class. I tell you once again. So it is cofactor. So transpose of the cofactor matrix, it is called adjoint of a matrix. Let us check. If A is equal to, it is a given matrix. Here 1 1 1 2 1 3, all these denotes the position. A11 means the element which lies in the first row and the first column. A11. A1 A22 means the element lies in the second row in the second column. Here it is the element which lies in the third row and the first column. So just like this is the matrix. Then adjoint of A will be the transpose of, it is given here, it is the transpose of the cofactor matrix. Transpose of cofactor matrix. It is, we already discussed it, cofactor denoted by alpha. So alpha 1 1, cofactor 1 1, it means cofactor of the first element. This is the first element 1 1. First row and the first column. So cofactor of first element, cofactor of second element. So we called this one as cofactor matrix. Its transpose we called as adjoint of matrix A. Okay, so let us do one problem. Find the adjoint of a matrix. Here it is a matrix 0 1 2 1 2 3 3 1 1. So transpose adjoint we know it is the transpose of the matrix formed by cofactor of the elements. So first we need to find the cofactor of all the elements. We need to find the cofactors of all the 9 elements. Here it is in the square matrix there are 9 elements. So 9 cofactors you should find it. So cofactor we know, we already discussed in the last video. Minor into minus 1 whole raised to I plus j. And the minor means it is the determinant value obtained when the row and the column in which it lies are related. So the determinant of the element obtained when the row and the column in which the element lies are deleted. It is minor. So minor and cofactor, please check the previous video. Okay, then find the adjoint of a matrix. Here it is a question. 0 1 2 1 2 3 3 1 1. As we discussed, we need to find first all the 9 cofactors or cofactors of the all 9 elements. First one, it is the first element 1 1, the element which lies in the first row and the first column. So cofactor of this one, cofactor of 0 is equal to minus 1 whole raised to 2. 2 means 1 plus 1. I plus j. I means the number of row and j means number of column. So minus 1 whole raised to 2 into the determinant of the elements by deleting the elements obtained after deleting the row and the column in which the item lies. That it is we called minor. So the determinant value of this one we call as minor. When we multiply that minor with this one, we will get cofactor. So that is equal to 1 into minus 1 whole square is equal to 1 we know, into its determinant value will be 2 into 1 2 minus 3 into 1 3. That is equal to, so 1 into minus 1 is equal to minus 1. So first cofactor is over. We calculate the cofactor of the first element. Then, for example, once again, the cofactor of 1, 3. So first row and the third column, this element. So if you want to find the cofactor of this element, it will be, so minus 1 whole raised to 4 into cofactor of 2 is equal to minus 1 whole raised to 4. 4, how we got? The 4, it is the total of this one. 1 plus 3, first row and the third column. Number of row plus number of column. 1 plus 3 is equal to 4. So minus 1 whole raised to 4 is equal to 1. So just for remembering, if minus 1 powered by an even number like 4 or 2, it will be 1. Then if the minus 1 it is powered by an odd number like 3 or 5, that will be minus 1. Okay. So minus 1 whole raised to 4 is equal to 1, we know, into the determinant value of. So if we are finding the cofactor of 2, so we need to delete the first row and the third column in which the element lies, the 2 lies. So the remaining item 1 3 2 1 1 3 2 1. So that is equal to minus 1 whole raised to 4 is equal to 1. We already calculated into its determinant value. 1 into 1 minus 2 into 3 6. That is equal to minus 5. Then it is cofactor of the element 3 2. 3 2 means third row and the second column. It is the cofactor of 1, this element. So cofactor of 1 is equal to minus 1 whole raised to 5. So 5, check, it is the total of the number of rows and columns. It is 3 2 position. So 3 plus 2, it is 5. Minus 1 whole raised to 5 into, so as I already told you, minus 1 whole raised to 5, that is equal to minus 1. Just check whether it is odd or even number. It is powered by an odd number, so it is minus 1. So into the determinant of, so delete the third row and the second column in which the number element lies. So the remaining 0 1 2 3, 0 1 2 3 equal to minus 1. Minus 1 whole raised to 5 is equal to minus 1 into 0 into 3 0 minus 2 into 1 2, that is equal to 2, minus 1 into minus 2, that is equal to plus 2. So this is the way how to calculate the cofactors of all the elements. So we need to find, just I just showed to you the how to calculate the cofactor of the three elements. The first one, this one, a11, cofactor 1 1, then a13, cofactor 1 3, then cofactor 3 2. Thus we need to find out all other remaining. So do the same work. You will get a12, the second cofactor will be 8. You can check it as it is described here. Then a21, this one, second position or second row and first column, it will be 1, the cofactor. The cofactor of a22, sorry, cofactor of 2 2 will be this one, 6, minus 6. Cofactor of 2 3, second row and third column, it will be 3. Then 3 1, third row and the first column, it is minus 1. Then 3 3, last row and the last column, third row and the third column, it is minus 1. So we need to just find all the 9 cofactor elements. Then after getting these 9 cofactor elements, as there is 9 elements, we got the 9 cofactors. We need to form the cofactor matrix by plotting all these cofactors in its order. So check. Then the adjoint of A will be, or A is equal to transpose of cofactor matrix, we know. So transpose of, like this, cofactor matrix. The first cofactor, it is minus 1. Just check here, it is a minus 1, a11. Then a12, it is 8. Then A13 it is minus 5. These are the first row items. You should keep all these elements in its order itself. Cofactor 1 1, cofactor 1 2, and cofactor 1 3. Minus 1, 8, minus 5. It is here minus 1, 8, minus 5. Then cofactor 2 1, it is 1. Then cofactor 2 2, it is minus 6. Then cofactor 2 3, it is 3. Then the last three items, cofactor 3 1, 3 2, 3 3. Just check the last slide. It is 3 1, it is minus 1. Then 3 2, it is 2. And the 3 3, it is minus 1. So minus 1, 2, minus 1. Yes, minus 1, 2, minus 1. So this is cofactor matrix. So our adjoint of matrix, adjoint of A is equal to transpose of this one. Transpose we know, we will get the transpose of the given matrix by interchanging its rows with its columns. So it is, its rows, first row it is minus 1, 8, minus 5. So it is taken here it as the first column, minus 1, 8, minus 5. Then its second row it is 1, minus 6, 3. Here it is taken as the second column, 1, minus 6, 3. Then the last row, here it is the last column, minus 1, 2, minus 1. So this is the way to find the adjoint of a given matrix. So first we need to find the all the cofactor of the all the elements. Then we need to find the cofactor matrix. Then we need to find the transpose of that cofactor matrix. So the transpose of cofactor matrix is called as adjoint of A or adjoint of the given matrix. Okay, all these are about adjoint. Okay, thank you. Thank you all.